In this video, we will discuss about SQL Server Query Optimizer estimates for queries with two predicates that utilizes OR clause. I'll be using AdventureWorks DW database for this particular demo. I'm going to create a table called table1 underscore temp. It gets its data from a table called table1. Once this is created, what I'm going to do is I'm going to execute this particular query, which basically selects the count of rows from table1 underscore temp, and the predicate is column2 is equal to Ramesh, and then I use a OR clause where column3 is equal to 439. So let's execute this particular query, and then let's look at the execution plan. And if you look at the execution plan, we have an table scan happening on table1 underscore temp. Let's hover the mouse on that. And then what we are able to see is like the estimated number of rows. The estimate here is like close to 375.8. So what we'll do is we will calculate, we will check like how did we get this estimate. So now what I'm going to do is let's look at it one more time. The estimate is 375.8. So now what I'm going to do is I'm going to run this query to get a list of statistics on table1 underscore temp. So we just created this table and then executed this query. As soon as we executed the query, the optimizer basically created two auto-created statistics on column 2 and column 3. So what we'll do is we will plug this statistics name on the DBCC show statistics command. Before running this and calculating the selectivity value, what we'll do is we will look at the calculation, how we will come to an estimate as far as a query with two predicates is concerned, where we have an OR clause as far as these two predicates are concerned. So the calculation is P0, P1, P2, P3 that are referenced here basically refers to the predicates that are used in the query. Again, in case if query has got more than four predicates, four columns in the where clause, then what happens is we calculate the selectivity for each of these predicates, and then we will pick up the top four predicates after the calculation. So in this case, what we are doing is we are doing this particular calculation here that we are seeing here, which is basically 1 minus 1 minus predicate 0 multiplied by 1 minus predicate 1 selectivity value, and then we do a square root. Same way we do it the same thing for predicate 2, and in this case we do a root of 4, and for the final predicate we do a root of 8, and we just multiply that once we have an 1 minus selectivity value for predicate 3. So now in this case, what we can do is we are rewriting this into this one, where we are changing the square root to power of 0.5, and same way for root of 4 to 0.25. So this is the calculation that we are doing, and once we have this calculation, we will multiply the resultant value with the number of rows on that particular query. So the main difference between AND clause and OR clause is that for the AND clause, we order the predicates using ascending order, but as far as the OR clause is concerned, we will be ordering the predicates in descending order. So just a recap on that. For multiple predicates on the query where you have an AND clause, what you do is you um, order the selectivity value of each of the predicates in ascending order as far as AND clause is concerned. But when you have predicates using OR clause, what we basically do is the selectivity values of each predicate is basically ordered by the descending order. That's the difference between AND and OR clause is concerned with regards to ordering the selectivity values for each of the predicates. But the formula is basically different for and OR, and for as far as OR is concerned, this is the formula. So now what we'll do is we will execute the DBCC show statistics command for column 2 first, and then let's look at the value. So here in our case, the value in the histogram should be Ramesh. So let's see if we have a direct hit as far as Ramesh is concerned. Going down, what we can see here is like we have a direct hit for value Ramesh in the histogram set. And what we see is that EQ rows is 302. So what I'm going to do is like I'm going to calculate the selectivity value. Selectivity value can be calculated using the number of rows that passes through a table with a given predicate divided by the total number of rows on that particular table. So in our case, what I'm doing is like I'm picking up 302 value and then dividing it by the number of rows that we have, which is 1,18,890. So let's run that and then let's take this value up and paste it here. Let's do the same thing for the next predicate also, which is column 3. So I'm going to run the DBC show statistics, and the value here is column 3 is equal to 439. Let's see if we have a direct hit for 439, but I don't see that. So what I'm seeing here is like value 439 is basically buried between 98 and 99 step. So the value 439 is between 438 and 432. So I'm going to take the average range rows, which is 148. So let me paste it here and then take the number of rows on this particular table and then get the selectivity value. So now what we'll do is like we will come up with these two values. So since it is an OR clause, we will basically be ordering it using descending order. So this is the um, uh, bigger value. So I will put it first. This would be the P0 and this would be the next value here. So what I'll do is like I will do the calculation. So if we see here, the calculation is 1 minus 1 minus predicate 0 selectivity value multiplied by 1 minus predicate 2 selectivity value, and we will find a square root of that. So what I'll do now is like I will first pick up this value and then put it here, which is basically my P0, that is predicate 0, and then I will pick up this value, which is your P1, and I will replace it here, and then I will do 1 minus selectivity value, and then I will find a square root for that and then multiply all the values with the number of rows that is present on this particular table, which is table 1 underscore temp. Let's execute it. So I'm getting a value of 375.8. So let me put it here. So now what I'll do is like I will run this query next to this calculation, and then let's look at the estimate value. So if I look at the execution plan, I have a table scan on table 1 underscore temp, and now if I look at it, the estimate value is the estimated number of rows per execution is 375.8. And now if I look at the calculation, it is same as that 375.8. So to check it further, if you see here, it is 375.8, and the value that we are getting is 375.8. So this is the calculation that the query optimizer basically performs when you have a query with two predicates and it utilizes an OR clause. So just a recap. So what we have seen is like we have a query that basically has two predicates and utilizes an OR clause. So what we basically do is like we calculate the selectivity value for column 2 first, and then the selectivity value for column 3. We basically calculated the selectivity value for column 2 and then the selectivity value for column 3. And what we did is like since it is an OR clause, the calculations would be like 1 minus P0 multiplied by 1 minus P1, and we find a square root, and then we will multiply that with 1 minus P2 root of 4 and so on. So what I'm doing here is like I calculated the selectivity value, and then I'm creating a predicate 0 and predicate 1 in as far as OR clause is concerned. When you have more than one predicate, that is when you have two predicates, what we do is like we calculate the selectivity value and then we order the selectivity value in descending order, and then we just perform this particular calculation. And what we were able to see is like after we perform this calculation, we were able to see the same value as what we found as far as the estimate is concerned. And with that, we were able to prove that the optimizer kind of uses this particular calculation to come up with the estimate value. That's it for this video. Thanks for watching. Have a great day. Jai Hind.